Hello all. In this session I am going to give you a complete overview of scales topic. Complete overview of scales topic, which is a part of engineering graphics, or you can call it as engineering drawing. Okay, what exactly a scale is all about, and what we are trying to construct, how to construct. I'm going to discuss about the types and conversions and how to do the construction of a scale, construction of any scale. All right, now coming to the scales types of scales, we have number one, reducer scale, and number two, enlarged. The name itself indicates to increase the size, we can call it as enlarged scale, or full length scale, you can call it as regular scale or same scale. Okay, let us first understand what exactly these scales are. What is a reducer scale? For example, if there is any big object, very large object like very big machine parts, I'll try to give some example. There is a very big machine part need to be drafted on a A4 sheet, which is not possible if the dimensions are beyond the sheet dimensions. Then such drawings, or you can say building structures, very big building structures, and you can say plans related to any residential or office plans. These drawings can't be drawn to the scale, same scale or regular scale or full scale. Okay, so those drawings need to be scaled down. That we call it as a reduced scale. Scale down in sense, I'll say 1:2. I reduce the dimension by 2 times. Okay, or else 1:5. Similarly, 1:100. I can scale down up to this much also. Some drawings are made of 1:1000 also, because you have to present everything on a sheet of paper, maybe A4 or A3 or A0 size sheet. Everything has to be presented, documented, and that has to be approved. Okay, you have to make others to understand. Someone has to interpret the drawing whatever you make on the sheet of paper. So for that case, we can't draw anything or everything to 1:1, or else full scale, regular, or same scale. So we are reducing it down to show it on a sheet of paper. So I just call it as reduced scale is 1:x. Okay, this x could be any number, that could be 10, 20, 30, 100, 1000. Okay, similarly, if it is an enlarged scale, I would say the ratio would be x is to 1. Means small or very tiny components like wristwatches, small gears. I'll just write down the examples. Wristwatches, or you can say gears, small gears which are used in watches and some other components, or chips used in computer. All these are very small component, minute component, which if I draw it on a sheet of paper or show it on a sheet of paper, it look very small. You can't understand the drawing and you can't see the dimensions properly. In such scenario, what we'll try to do, we try to increase or enlarge the size of the component. In place of x, I may increase by 2 times, or I may increase by 10 times, or it may be increased by 100. Okay, small components like wristwatches, small gears, or any tiny components are enlarged, okay, to show it on a sheet of paper. Similarly, the third one is full scale, means whatever the dimensions or shape and size are given, it will fix to the size of the paper. There is no problem to show it on a sheet of paper to the actual dimensions, nothing but actual dimensions. So such case I call it as 1:1. Okay, so we are not going to reduce, we are not going to increase the dimensional changes. This is what the three types of scales are. Okay, now coming to the scale, one word comes into picture which is called representative fraction. Okay, scale is also same as RF only. Representative fraction always represented with RF in short. Okay, RF nothing but representative. This RF is very important, representative factor. Okay, for to draw any scale, that could be there are different types of scales like a plane scale, diagonal scale, vernier scale. So to draw any scale, RF is very important, and RF value will be given to you in the question. Okay, so there is a small confusion that RF is different from scale. It is not. Okay, scale is also same as RF, but only difference is RF is always represented, this particular RF is always represented or expressed as a ratio, let us, or something like this, 1 by x, or it could be x by 1 in terms of fraction. This is always expressed in terms of fraction. Okay, but scale is always expressed in terms of ratio, RATI. Okay, maybe it could be 1:x as I discussed before, something like this, or else x:1, or these are the things you need to remember. There are T types of scales followed by RF values, more and more important. Okay, RF is a representation of proportion of a drawing. This particular RF is representation of, let me write it down here, RF is representation of proportions. Try to understand proportions of the drawing. I'm going to explain all these individually when I actually go on to constructing the scale. Okay, with respect to actual drawings or actual size, let us say actual size. All right, sometimes RF is also called scale but is expressed in ratio. Okay, sometimes RF can also be represented something like this in few problems that I'll show you when I discuss the construction. Okay, till his, if it is clear, now let us see what is RF and how the formula of RF is written. Okay, let me clear this window and show you that. Now RF is always represented something like this. Representative fraction is always represented as length of the drawing, upon actual length or actual drawing. Alright, this is what the formula is. So actual drawing length will be given, accordingly we will convert length of the drawing by actual length or actual drawing. Okay, now whatever might be the units given, try to convert length of the drawing or actual drawing into centimeters, as we can measure only centimeters and millimeters with whatever the scale existing. Let me show you with a simple scale. This is how we use a scale, right? Just for your understanding purpose, let me consider this as 0, 0. If that is 0, 0, then have a look here. I consider this as a point 0, 0. Okay, now let us consider this as from here to here 10 mm, 20, something like this. Till this point I'm calling it as 10. Then this is some line, I'm dragging a line. Okay, now with this scale, whatever the scale you are using, with the help of a drafter or a single scale, you can measure centimeters and millimeters. Okay, for few scales you have even if you rotate to the other side of the scale, maybe the other side of the scale, you can see inch information also. Okay, but if somebody asks you to draw a scale which can measure kilometers, which can measure meters, you can't measure kilometers and meters with the help of the scale which is available, engineering scale what we are using. So in such case, we try to construct our own scale which can measure a distance of meters, kilometers, decimeters, decameters. All the order will be there, conversion of order will be there. That all I am going to discuss now. Alright, now for example, RF is equal to length of the drawing by actual drawing, as I said, and whatever the RF value might be, you have to convert complete, because as this is a ratio which is a unitless. Okay, you have to convert length of the drawing in centimeters and actual drawing in the same units, and when you calculate, obviously you are going to get a unitless factor only, where both the units will get cancelled. Okay, and measure up to distance will also be given, what scale has to be drawn and what should be the length of the scale. Okay, RF will be given to you in the question, followed by, and maximum length will be given to you. Number 2, let us call this a number 1. Number 2, maximum length will be given, maximum length will be given, or else the same they call it as measure distance, measure up to distance will be given, or read up to distance will be given. Okay, anything is same, just to the terminology might be different, all are same. Now what are the two things given in the question means, representative fraction will be given to you, maximum length will be given to you. Just by making use of these values, you have to construct the scale. Okay, just by making use of these, we need to calculate length of the scale, that is equal to RF into maximum or measure up to distance, measure up to distance, whatever given to you in the question. If you calculate these, you get length of the scale. Length of the scale is nothing but the scale or the length which you are supposed to draw on a sheet of paper or a drawing sheet. Okay, so this particular second point, maximum length or measure up to distance, this you need to remember. Technically the question might be very tricky, that we need to understand. Okay, so now let us see one more important point, just now as I said, RF is the most important point need to be remembered, which we need to calculate RF. Okay, so coming back to our discussion, number 1, there is a reduced scale or reducing scale. Number 2, enlarge. Number 3, full size or full scale. Okay, now here coming to reduced scale, RF is always less than 1. So you just understand, RF will be less than for a reduced scale, and RF is going to greater than 1 for the enlarged scale, and here it is equal to 1. This is one of the point to be noted for all the three cases. Before we have seen what is reduced, enlarged and full scale. Now as we know what is RF, based on RF, if it is less than 1, reduced scale, greater than 1, enlarged, if it is equal, then we call it as full or same scale. Okay, this is keeping this in mind, let us try to solve few problems. Okay, now before moving on to solving any problem, let me give you clarity upon what is RF. As I said, RF is equal, for example, something is given as RF is equal to 1 by 4 given. Okay, as I said just now about 1 divided by x or x divided by y, and one more data is given, maximum length or measure up to is equal to 5 dm, decimeters. Okay, I'll tell you what is decimeters units also. Now to calculate length of the scale, because we ultimately we need to draw on a sheet or a drawing sheet by using centimeter and millimeter scale only, so we have to convert everything into centimeters. Okay, LOS is equal, length of scale is equal to 1 by 4, which is RF, into ml, that is equal to 5 decimeters, that is equal to 1 by 4 into 5. If I want to convert this particular decimeters to centimeters, what is the conversion? That is equal to 10 centimeters. 1 decimeter is equal to 10 centimeter. 1 decimeter is equal to 10 centimeters. So I'm multiplying 10 with 5. Where I'm going to get what? The dimensions are something like this, which is equal to 50 by 4. If I calculate, finally I'm going to get a dimension 12.5 centimeters. Alright, now what is this? Few people might know and few are getting confused, I think so, because the conversions are very much important here. Try to understand the subunits are very much important. Conversions, number one, the smallest unit I call it as millimeters, then centimeters, you have a decimeter, meter scale, decameter, capital I'm calling it as decameter, small as decimeter, hectometer and kilometer. Those who don't know, try to remember in this order. Okay, so in general what we'll try to do, if I want to convert kilometers to meters, I multiply the number with 1000. How you are converting? For example, if I am going from bottom to top, for example, how you are converting it to 1000 means 1 kilometer to meter, 1 2 3 steps you are going, means after 1 3 zeros, I'm trying to take 3 zeros. That is what I do the calculation. So now whatever the number, for example 10 multiplied with 1000 will give you 12 kilometers. Let us say 10 kilometers. I am converting 10 kilometers to meters. Okay, so if I multiply with 1000, everything will be converted to meters. Okay, I am converting kilometers to meters. This I am calling it as decimeter, small d, and this as deca, capital. So if this, keeping this in mind, if you will see 5 decimeters are given to me, 5 decimeter into 10 it will be converted to centimeter. So altogether I got 12.5 centimeters. Now it becomes easy for me to draw a length of 12 centimeters on a sheet. It is easy. Alright, that is the reason I am converting to my convenient units. That is what I am trying to do. Similarly, let us take one more simple example. Let me take length of this scale is equal to, we need to calculate RF value is given, or else directly I try to go with the problem solving. Okay, keeping this in mind, let us solve a problem so that you'll understand better. Let me erase this conversion and start with a simple problem. Let me take a simple problem now. As I said, RF value will be given. What is given in the question? Directly I'll try to give the RF value. Let me take some value. RF is equal to, let me take RF will be given, and maximum distance or measure up to distance will be given, as I said in the beginning. Let us take RF is equal to 1 by 5 and read up to a distance of 1 meter. Okay, these are the things I'm considering for my case. Okay, construct a scale of RF is equal to 1 by 5 and measure up to a distance of, or read up to a distance of 1 meter. Okay, and read decimeter and centimeter on that particular scale. This is my question. Okay, keeping this in mind, try to calculate. For example, RF is given, so I need to calculate length of the scale. Length of scale is equal to RF into maximum length or maximum distance. Okay, 1 by 5 into what is ml? 1 meter is given. 1 meter is given. Okay, if I want to convert meter to centimeter, 2 zeros, nothing but 100. That is equal to 1 by 5 into 1 into 100. Alright, so finally I'm going to get, if I calculate 20 centimeters. Now 20 centimeters is very much easy to draw. Let me take the scale. Okay, then let me draw a length of 20 I'm considering some point somewhere here or else here for your understanding. From this long length to this long, I let me take it as, for your understanding, this distance 20. So some distance I'll draw first. Okay, this I'm taking as I'm drawing it conventionally. I take from this line to the next, this as 10 mm or 1 centimeter. 1 2 3 4 5 6 7 8 9 10 11 12 13 14. Okay, so let me take this as 20, this up to here as 20 centimeter line roughly, because I can't go beyond. And after this, the height of the scale should be, the height of the scale should be 1.5 centimeter, or width of the scale should be 1.5 centimeter. Again I'll draw one more line here. Okay, and I just try to close this like a box. All right, this like a box. Now I need to divide this. I just need to convert complete thing into a scale. Okay, now before converting that into a scale, let us see what exactly the scales are, how it got classified. Coming to the scales, it is divided into four types. Four types of scales are there. Number one, plane scale. Number two, diagonal scale. Then you have vernier scale. Fourth one, comparative scale. Okay, now we are discussing about a plane scale. What is a plane scale? Let us see. Okay, plane scale can read up to 2 units. Up to 2 units. Those 2 units could be same or different. Okay, if I'll say I need to measure a distance of 5.2 centimeters. What does it mean? 5 centimeters. Then what is the subunit of centimeter? Millimeters. So 5 centimeters, 0.2 millimeters. Similarly, if I want to measure a distance of 6.4 decimeters, then 6 decimeters, 0.4 centimeters. So I can measure up to 2 units with 1 decimal point only, with 1 decimal point. Okay, similarly, coming to a diagonal scale, I can measure up to 3 units. I can measure up to 3 units for followed by 2 decimal point, minimum of 2 decimal points. Okay, for example, 6.42 decimeter means 6 decimeters, 0.4 centimeters and 0.02 millimeters. Means I am trying to see all the subdivisions also, subunits also. Okay, keeping in this mind, we'll try to construct a scale now. So coming back to vernier and comparative, I try to discuss in the upcoming lectures. Okay, now let me divide this scale. As you know from our basics, like if we have a scale of centimeter and millimeter, if I'll say this is 1 centimeter, it is divided into 10 parts. 1 centimeter is equal to 10 millimeters. In the same way, I have to construct the scale for both decimeter and centimeter. If that is the case, how many parts I need to divide? Up to what distance we can measure? Means we can measure up to 1 meter. 1 meter maximum. Now the division depends on whatever the maximum distance given, or measure up to distance given, or read up to distance given. The measure up to distance given is 1 meter. As this is 1 meter, this one segment is nothing but 1 meter only. But we need to have divisions where I need to measure decimeter and centimeters also. If that is the case, I have to divide this into some segment. What is the number of segments you are going to divide? 1 centimeter, sorry, 1 meter. 1 meter is equal to 10 decimeters. 1 meter is equal to 10 decimeters. So I divide this complete segment into 10 parts. Okay, complete thing into 10 parts. So how I divide? Again division, we need to divide this into 10 parts. I can do with the help of a compass, or else you have a simple concept like dividing a line into number of sections. Take any acute angle, okay, then draw. I'll change the color to light somewhat. 2H pencil, with the help of 2H pencil, construct, draw a line which is not visible. Let me change the color to some yellow, light yellow. Okay, I drag the line of infinite distance. Then I'll try to divide this particular line with my convenient dimensions. Okay, let me take green color and divide. I need to divide this to 10 parts, maybe 10 mm each. 10, 20, 30, 40, 50, 60, 70. This is the last division. Now the last division you are supposed to, last division should be joined with the end point of the scale, like this. I think most of you know, but still I am trying to explain. After this, this is my last point. I'm trying to align the last point with the end point of the scale. This is the end point of the scale. This is my last division. This last division I'm joining with the end point. Okay. Then take the scale to the next intersection. Draw a line. Similarly to the next. Draw parallel lines by taking the drafter scale to the each and every intersection. Draw these lines. You get number of divisions. Alright, something like this. It is taking enough time as I'm drawing it conventionally. So on a pen tab, so it takes time. Alright, so divided now. So whatever the divisions I want to make it on the horizontal, I try to make it with my convenient distance on the inclination. What should be the inclination? What should be this inclination? Means any convenient angle, any acute angle. Alright, so this is 1, 2, 3, 4. Likewise you got it. So accordingly what I do, at every intersection I try to drag a vertical. 1, 2, 3, 4, 5, 6, something like this. Okay, I don't waste time now. Simply you people can practice this by looking at the discussion. Something like this. Now I'll try to give numbering from the first division, 0, 1, 2, something like this. Now every construction whatever I made till now should be with only 2H pencil. 2H pen light, it should be light in color. Alright, let me erase few things which are not required from this portion so that I can write exactly what are required. Okay, few things I just try to remove. Now try to see, after constructing this particular scale will read two units. One is decimeter, one is centimeter. Decimeter is the bigger unit, so always try to write decimeter to the right side of the scale and the subunit to the left side of the scale. In between you are supposed to mention RF, that is equal to 1 by 5. Okay, in between. Then everything should be with 2H color or 2H pencil only. Now the first division, because for example as I said, plane scale will read up to 2 units. If I'll say it is I need to measure, or I need to measure a distance of 5.2, 5.2, 5 is, this is the actually a decimeter scale. The main scale is decimeter, subdivisions are centimeters. So 5.2, I can't place 0.2 to make a division or a subdivision. To measure the subdivision, divide the first division into 10 parts. Divide the first division into 10 parts. For this case also same thing you are supposed to practice. Same thing in sense, draw any acute angle, divide this into number of parts and join the last end point with the 0th division, then try to divide in 10 parts. Okay, as of now I try to take only one single division. Keep it here, 0 1 2 3 4 5, this I call it as 5 6 7 8 9 10, this is 10th division. Okay, in between I have 4 points, in between I have 5 and 10, in between 5 and 10 I have 4 more points. Okay, now if I want to measure 5.2, one leg of dimension will be on 5, one will be on second division. Accordingly I can easily measure. Okay, this is how a plane scale will be measured by using the conversions and given dimensions. Alright, and let me take one more simple problem of a plane scale. In the other upcoming lectures I try to explain you diagonal, vernier and comparative scale also. Let me clear the complete window and I just try to come up with a simple problem again. What is that problem means? Let me take given dimensions as, or given data, RF is equal to 1 by 50 and measure up to a distance of let me say 6 meters. So this is the data given. By using this data we need to construct a scale where I can measure meters, and decimeters. Why decimeters? Because I think I have deleted millimeter, centimeter, decimeter, meter, decameter, hectometer and kilometer. This is the order I have mentioned, no? So now meters are given to you. This doesn't have any units, unitless. Meters are given. Next subunit is what? Decimeters. So if you create or construct a scale of meters, obviously it is going to measure 2 units. What are those two? One is the main unit, one more is the subunit. Okay, that is what it means. You should understand this. Okay, now we need to calculate length of the scale, that is equal to RF multiplied by maximum length, that is equal to 1 by 50 multiplied by 6 meters given. Again that we need to convert. 1 meter is equal to how many decimeters or centimeters. Now to draw the sketch on a sheet of paper, again we need to convert whatever might be the question, we need to convert everything into centimeters. Whether the question might be given in meters or kilometers or decimeters, but you have to convert everything into centimeter, because your scale can measure only centimeters and millimeters. Either you can convert millimeters also, not a problem, but try to remember, always try to convert into centimeters. It becomes easy for you to construct the scale. Okay, to convert from meters to centimeters, 2 zeros, nothing but I need to multiply it by 100 by 100 centimeters. So altogether what you are going to get 600, so which is again 12 centimeters. Try to remember 12. Now the length of the scale is 12, so you need to draw a length of 12 centimeters. Conventional I try to represent now. I just take it to 0. I'll take a scale of 0 degrees. I'll try to place it here. Then I'll change the color. I'll drag a length of, let me take this as 12 centimeters conventionally. Alright, because I can't draw it to the scale, it will take enough time. This length should be 1.5 centimeters. Then again draw one more line of distance, one more line. I'll try to close this. Okay, let us consider the length of this complete length is 12 centimeters. Now I just need to divide this into some segment. What number of segment I need to divide? Whatever the measure up to or read up to or maximum distance is given to you. 6 parts. 6 parts. So divide this into 6 parts. If it is possible with a compass, directly divide it, or else again the same concept. Where, what is that concept? Again I just try to repeat. Draw one 2H line of any acute angle. Okay, now with the convenient distance 10 mm or 15 mm, divide this length into 6 parts, 1 2 3 4 5 6 parts, and join the last point with the end point of the length of the scale, and try to draw parallel lines. 1 2 3. I'm not drawing, it is maybe conventional I'm placing it, but still you people can do properly with your drafter. Alright, these are my divisions. Everything has to be constructed with 2H only. Now once you get this, try to project it vertically onto the top horizontal, something like the second division. It went wrong. Third division, fourth one, then the last one. Okay, means we are trying to make some 6 parts of length of the scale, or else directly you can say 12 divided by 6, whatever the number you get accordingly, but that can't be measured, that 2 centimeters, whatever the thing, if the length is uh, 10 mm or 12 mm or 15 mm, then it becomes easy. If it is very small division, then it is very tough to draw with a compass. 12 centimeters is fine, you can directly divide it, not a problem. Now this particular scale reads millimeters and meters and decimeters. Okay, so how to place the division? This first division, 0th division, 1 2 3 4 5, 6 parts, 5 numbers I got it. Okay, now the first division I'll try to divide it, a central line at 5. This is 5, means 10. So this will read the subdivisions decimeter, this will read the main divisions meters. So meters, meters, meters are placed to the right of the scale, and decimeters place it to the left, and RF always placed in the middle, which is 1 by 5, 1 by 50, 1 by 50. All right, now the division will be something like this. This I have one more, first division, second division somewhere, and so likewise you have to do. It will take time for me. Okay, so 0 1 2 3 4 5 6, sorry, 5 6 7 8 9 10. So likewise you have to divide. Okay, and if one more point will be given to in the question, and mark a distance of 4.2 meters. Finally, once you construct, do this and mark a distance of 2.5 meters. Now how you mark it? I'll take a light color. As they said, 4.2, 4, one dimension leg on 4, one dimension leg on 2, and a dimension line followed by an arrow. Okay, for the before problem I didn't make this. Now number whatever asked, which is 4.2 meters, means 4 meters, and 0.2 decimeters, means this subdivision will read decimeters, main divisions will read meters, and whatever the representative fraction given, that has to be written in the middle. Complete construction has to be with HB pencil, and the divisions also, the complete rectangular box, draw with, darken the rectangular box with HB pencil, and the divisions with HB pencil. Okay, all others should be with 2H pencil only. Again, one more marking I make, 2.5, one leg of dimension on 2, one on 5.5 as a, and a dimension line. something of this kind, and an arrow, fill the arrow, that is more important, and try to give a number whatever asked in the question. 2.5 meters, so 2 meters 0.5 decimeters. This is about a simple plane scale construction. And what should be this dimension should be 1.5 centimeters. Okay, this dimension should be 1.5 centimeters. Okay, or else you can say 1 centimeter is also fine, but that is the standardized one. This is one more problem based on plane scale. Okay, in the upcoming lectures I'll try to solve more and more problems, and I'll show you how exactly we need to construct a plane scale, and followed by I discuss diagonal, vernier and comparative scales also in the upcoming lectures. This is all for the session. Any queries you can comment in the box given below. Thank you.